Hey everyone, I just wanted to show you guys today how to use the Ethereum client to download blockchain data and include it in your application, in your front end perhaps. So let's start by considering how do you actually pull data from the blockchain. So let's say we want to know which transfers happened of a certain token. Let's say Shiba Inu. How many how many transfers and in which blocks were Shiba Inu transferred? Let's say we have questions like that. So there are a couple ways to do this. One is you can, create your own node, right? You can host your own node yourself and just scan through that and get the data, and we'll see how. Or you can basically excuse me, connect to someone who has already created a node and who are just serving you their data. So that's using a provider, basically. Some examples are Infura, Alchemy, Morales, etc. There are others, Etherscan, and so on. And then there are different frameworks for doing this. You can do this in Python. You have Web3.py. You can do it in JavaScript. That's what we'll be doing today, and we'll be using the Ethers framework. And then something to notice: you can directly connect to the Ethers client. So basically, the way it works is that when someone runs a node, let's say it's not us right now, it's someone else, right? Obviously, the blockchain is consisting of many nodes in a network that communicate to each other, send data to each other and information and so on. And they're ideally very independent, or at least enough are independent so that there's no collusion and the network works as expected. So the very boiled down description of it. But the point is that these nodes, we can actually connect to these nodes. Okay, and what they'll serve us is an RPC JSON endpoint. So we can basically ask these nodes for information. We can say, hey, which transfers happened of Shiba Inu in the past 10 blocks and so on. We can ask these questions through that interface, like through that API, basically. So we can write an application that can talk to them. Now, I mentioned these providers, that also kind of sit on top of everything, because instead of us connecting directly to another node, or even as mentioned, we create our own node, there are these providers. And why would we use them? So basically, they typically provide a very rich and enhanced API for us to use, so they're worth using. So to give you an example, maybe you want to find out everybody who owns a specific NFT or something like that. So if you want to do that, yeah, you can crawl through the blockchain, you can scan it via the node, and you can kind of manually do that. Or maybe there's a very rich API. Let's say we go to Alchemy and they have something like get all owners of this NFT, or get the transaction history of this NFT, or get all the NFTs that this account owns. Like all these kind of questions that can get kind of just a little bit intricate and require some engineering on your side can already have been done for you basically through these providers. So they can be worth using. Today we'll actually use Alchemy just for that. They have a way to get all the transfers of a given token. So let's say Shiba Inu, they have a way to essentially say, here are all the relevant blocks where Shiba Inu participated in transfer wise. So that's what we're going to do. And then that's a little bit of background of what's happening. So, all right, let's get to it. So basically, here's the code that I put together. So if you actually watch my latest live session, I think it was from this today, September 10. I think it's a week ago or two or so. It's on the channel. But I walked you kind of through how I started setting up the front end. Now I'm not a front end engineer, so I was going through a little bit of a struggle, but we got it set up. And since then, I actually finished it. It didn't take too long. Beyond what I did in that video, it just took a little bit of a learning curve to get caught up. But anyway, today I just want to show you some of the backend as well, like how we're actually pulling the data. So this is the code. I'll just show you first how the final product ended up. So I ended up deploying it with Versal, and yeah, this is how it looks. So you'll recommend this from our live session. I cleaned it up, so it definitely looks a little bit different, but not too different. It has the same concept. So I have this dashboard. I have a link to my Twitter. Feel free to follow me. And feel free to subscribe, follow this channel as well on YouTube, you know, if you like this. And any suggestions how I can make the content better, please let me know. But basically we have a header here, and then we have the input box where, you know, you can put whatever token you want. Right now it's Shiba Inu actually, and it'll tell you below. So we're going to pull that data. I'll show you how that works in the code. And then we'll even show you like what's the latest block. And I actually clicked this link right here, but that's an example transaction, this link right here, that just shows you the block. And as you can correctly see, the tokens transfer to Shiba Inu. So I'm actually just watching Shiba Inu right now on this front end. And as you can see in the bottom left, it has transfer volume in millions tokens. So you can see, oh, in this block, 549 at the end here, you know, 200 millions were transferred basically. You'll also see the block base fee and basically the gas usage in percentage here. So basically gas used of the gas limit of that block to the right. And we'll get back to that, how this works in a minute. And then you can plop in whatever ERC20 token you want. So I included a link here for you. So you can just go here and say, actually I want to see Tether instead. So let's go ahead and copy that. And actually just what you can do is just go here and insert it like that. Boom. You see how the token updates immediately here? You can click update if you want. It actually auto updates every block, but if you don't want to wait just for this token to show, you can just click update, and then if you click that link, you can see now you see everything that Tether is included in. Now again, this is just one example transaction. As you can see, it also says example transaction. The point is there are more transactions in that block, of course, right? A block has multiple transactions. But it just helps you like kind of just make sure everything makes sense. You know, you can kind of get a good idea of that token. Good. So that's how the front end looks. So it did end up look pretty good, I'd say, like overall, especially from where we started. We started from scratch, right? Okay. I used a look back number of 20. So what's going to happen in this application, you just saw we have the transfer volume, we have the base fee, we have the percentage gas usage in that block. We're going to look back 20 blocks and we're going to make that plot, right? We will go all the way back to the Genesis block, but we're not going to do that. That would be a lot of data. Okay. So I just want to highlight some key things here. One is that we're using, as mentioned, we're using Alchemy. So let me scroll back up. So the Alchemy has an SDK. So you just need to say npm install alchemy-SDK, essentially, right? Go check out the latest install instructions, but that's basically what it is. And then we can, you know, import network and we can import Alchemy. You can see we have these settings here where we need an API key. So what you need to do is go to Alchemy. Always just Google it. I'm not going to tell you a link because you got to be careful following whatever link someone tells you, right? So go on Google, search Alchemy. You know, if something comes up with like Alchemy and gold and so on, just say like Alchemy crypto, whatever, and it'll take you to the Alchemy website. There, you just set up an account, you create your API key, you put that right here. Now, if you push this code to an official repo, like GitHub or whatever, just don't put your key here. You need to basically pull it from your environment, okay? Notice also that we imported network from Alchemy, so we can actually just, they already have a preset variable network.eth mainnet. That's exactly the network we want, so that makes it pretty easy. Okay, with these settings, you can see down here that, right here, I'll get closer to the code here, that we're setting up a new Alchemy object here, or an instance of that class, basically, against those settings. So we're on ETH mainnet right now, and we have our API key. Excuse me, I'm a little bit sick. Sorry about that. So once we have that Alchemy set up, you can see the token metadata I was talking to you about here. I'll try to point right here. There you go. That token metadata is what we're getting right here. Okay, so you can see that we're connected to Alchemy. You can also see Alchemy has different, you know, kind of like methods here. So or modules almost. There's a config, so that's helped to configure Alchemy. There's also a core section. There's this dedicated NFT section. There's a transact section, and there's a WS, which is WebSocket section. So we'll get to that in a second. But a lot of it lives on the core. And you can see all these methods here, like VS Code does a good job here in showing me, but of course they also have documentation you'd have to go look at. But as you can see, you can do estimate gas. That's always good before you send a transaction, so you can submit the gas that's necessary, or at least the estimated necessary gas. You can get asset transfers. We'll look into that in a second. You can get the balance of an address. You can get the block, but, you know, given the block hash or the block number, you can get the block number. Which just gets the latest block number. You can get the block, but make sure you include all transactions, and so on. So some of these are the same as you'd get if you did not use Alchemy, but just use, say, Ethers or whatever, like just basically connect it directly to a node in the network, right? They're handling some of that for us. They're connecting to the node, and they're serving up their own API that's a little bit more enriched. So you're not gonna, like, let's say we connect it directly to a node, we're not gonna see this method get asset transfers. That'll be more raw methods, so to speak. But we will still see things like, get block number and get block and so on. Okay, cool. So that's how the metadata comes about. You just need to call get token metadata, and you need to give the token address. That's what the user inputs in the input field. And the way that it works is that when the input field is updated, the state of this React application is updated and the contract address is updated as well. So anyway, so that's how to do that. And you can get things like symbol, name, logo as well. So that's what you see there. Now, next, we want to actually pull all the transactions that involve, say, Shiba Inu or whatever. So what we're going to do is we're going to create a WebSocket and we're going to create a filter. So we're basically saying filter for everything that has to do with these events. So we've talked about this before, but a Solidity application can emit events, and the front end can search for these events and display them. So it's a very good way to communicate between the blockchain and other applications using it. So we're going to look for events that look like this. They're transferring from an address to another address a certain amount, a UN256. So that's the signature of that transfer event, and that's what we're going to use here. We're going to say, hey, we want to look for these topics. When you also note that in the event, when you can index each of these variables, it makes it easier to find what's happening. So these are definitely indexed in the ERC20 standard because they're indexing from who to whom, and that makes it easy to find. Notice also we're going to use this in the filter, this address. So we're going to say any transfer that involves this address, like this token, basically Shiba Inu, and you can transfer from anyone to anyone else. Okay, that's what we're going to be looking for. And then you can see we start our WebSocket right here. We say alchemy.websocket.on this filter, do this stuff when that filter triggers, when something like that happens. So, in other words, when a transfer of Shiba Inu happens between any two parties, basically call this code. And what we're going to do here is we're going to get the latest block. We're going to go back 20 blocks, and we can define, again, this is a constant we can define, and we're going to say from block to block, please get all the asset transfers. Don't exclude or do exclude zero values. And we're going to look at all ERC20 transfers. You can also do external and internal transfers as well. There's a lot of information, documentation, what that is. And then we can say, but it has to be just transfers again that look at this contract address. So Shiba Inu basically. And then just get from that call, just get the dot transfers. So we're just going to get back a list of the transfers. Okay. That's it. Now we can process them here. So right here, we're going to loop over all the transfers we got back, and we're going to get the block that each transaction was involved in. There are some ways we can speed this up and make it more efficient, but this is just very kind of raw. You can go see the code on GitHub, so it's just more educational so you can see what's happening. But anyway, we can get the block, and then from that, we can actually parse the block number, and we can push that to another array we have, and we can get the base fee. So what this is like, what is the base fee for each transaction in that block? I'll talk to that about in a second. It's the EIP 1559. We can get into that. And then you can also get the gas used over the gas limit. Excuse me. And you can actually divide those into each other and multiply by 100 to get a percentage. Okay. Then after that, now you have the three arrays, so we can basically just plot them. And we're going to use chart.js for that. Yeah, and then let's go look at the plot. So just to give you one example, here we're just putting together, I'll skip that because that's just the same code. It's just, it just run once when the application loads. Let's go to the plot. Yeah, so right here. So from chart.js, we're actually going to use the line plot. And all we do is just pass in the data. Now this is used as a state in this React application. And notice we'll also have some options we pass in. That's it. That's really it. And we do the same for all the other charts. You can see here, I commented in the code here, the left chart, the mid chart, plotting the base fee and so on. That's it. That's the essence of it. Let's go back here now and talk quickly about these base fees and block usage and percentage. So What is happening here is that there was a change made to Ethereum EIP 1559, and basically what it was about was, instead of all folks basically creating like transactions and putting their own gas price on their transaction for the miners to pick, it'd be like a pure auction system where even in high congestion times and low congestion times, like there was no distinction per se. It was just an auction, and everybody would just shoot super high for their price. They'd say, "Oh, I want to pay blah amount of dollars per gas," and then that number was super high, so they made sure they got involved or got included in the block. So what happened was, you would get a lot of transactions like that piled up in high congestion times, and there's just be the mempool would just be full of that. And even when the congestion went down and became, let's just say for this example extreme, like near zero, the backlog would still be huge with those like transactions, right? So what they were hoping to do with 1559 is that we're gonna not just have like a free for all auction like that and just let it go wild, and even if the congestion is low, you're still gonna get completely clocked by these high gas price transactions. What we're going to do instead is we're going to break it into two. So we'll have a base fee. That's the underlying fee that everybody pays no matter who you are. And then on top of that, sure, we'll add a tip. Like so we'll basically still have kind of like an auction system a little bit, but on top of the base fee, right? So in a high congestion time, the base fee will be huge and will deter people from submitting transactions, again, unless it's really necessary or they can afford it. So the base fee is going to be great. Are going to be really high, and the tip that someone puts on top is going to make sure that they get prioritized, and it's going to be some large number. But now if the congestion goes to zero, this base fee will basically go to zero, and so now the tip they paid will be like very small, so others can step in and like kind of pay more and be included in the block, right? So that allows other actors to come in, and I mean, of course they can resubmit at a higher tip, but fine, whatever, that's fine, that's a free market. But the point is, it's not going to just stick around with this constantly high fee that they originally submitted. That would be like equivalently lower in a low congestion. And then they can resubmit if they really want it in, or just like leave it and wait for it to be transmitted. So it should also deter you a little bit in high congestion to really like add a huge like tip on top, because the total will be so much larger than before, right? So it should also kind of deter people from just like submitting huge like gas prices, because that base fee is can be wasted a little bit if it just goes to zero. So there are there are a lot of reasons for why they did that, and it was just really to make the ecosystem better. So how do we see that in effect? Well, if you look at the middle plot here, the base fee, you can see it's actually been increasing. You see that from block 52. So from block 52 here in the very edge on right here, to this block here, 72. I'm just using the last two digits here, but there are 20 blocks there. But the point is that it's just been increasing. Why is that? Well, so basically that's because the gas usage, basically how full the block is, so to speak, like kind of a proxy for network congestion, has been pretty high. You see that from 52, it was a little over 60%, and then it actually went to 100% a couple of times. And that's why in the background, the base fee has been increasing to, again, deter more actors from entering the block. And you can see as a result, there's definitely some oscillations in the block usage, but you do see it dropping pretty low at one point, like almost 15%. Did come back up again. So these two are, they vary with each other. They're dependent. So like basically the independent variable is the block usage in percent, right? So if that is at 100%, well then now base fee will have to increase to deter usage. And if it's very low, well, base fee will go down. So that's how they vary with each other. It's a little bit jagged here, but we could do a separate plot. Maybe I'd prefer that to kind of just show it over a longer time period and smooth it out and so on, so you can kind of see the trends and so on. But yeah, so that's how it works. Good. Okay, cool. So anyway, so you can actually go to this URL right here, up here. Feel free to type that in. I'll also leave it in the comment section. And you can actually just play around with this application, put whatever token you want, ERC21. You can see this. You can go to my GitHub. You can see my code. Just feel free to clone it, and you'll get exactly this. And I even included deployment steps for you, so you can even deploy your own version with Versal or Surge or whatever you use. All right, so that's it. So feel free to follow me on Twitter. Feel free to follow me on this YouTube channel. Give it a like if you like the content. Leave your comment about what you like better. Do you want me to code live? Do you want me to show the code differently? Do some other applications. It was a lot of fun to put together, and it really teaches you about how to pull blockchain data. And if I were to recommend something next, would be to maybe do it a little bit more manually. I used Alchemy, which helps me a lot, right? Because they have that enhanced API. But you can even do it more raw, as I covered earlier. It's like you can just pull directly from a node and get the actual and use the actual RPC JSON endpoint. So we can do a follow-up video of whatever you want. But yeah, thanks for watching, and yeah, take care.